So in the final part of section 3.2, this is part 4, we have the graph of two different functions, and I've graphed them in two different colors so we can tell them apart. So my f function is in blue and my g function is in red. They're on the handout, but there they are graphed on the board also so we can talk about them. And we're going to use these two functions to answer the following questions. So the question they're asking is what is f plus g of 5? So again, the 5 is the input value. So we're going to go and find x equal to 5. So x equal to 5 right here. So the blue picture is showing me an output of 1. So f of 5 is 1. But I also need to add to it g of 5, and g of 5 is 4. So I'm adding 1 plus 4 and getting an output of 5. So again, I went to the x value of 5, that's over here, and I'm looking for the output values for both the blue function and the red function. The blue function has an output of 1. The red function has an output of 4, so I'm going to add those two outputs together. Okay, now you have to be very careful when you subtract. The order of operations is important here. So this is telling me to find g of 7. So I'm going to come out here to 7. So here's 7 for my input value, and I need g. So g of 7 happens to be 5. That's the output value for the red function at 7. And for the blue function, which is f, our output value is 3. So we're going to do 5 minus 3 and end up with 2 as an answer. The next one's asking us to do a product, f times g of -1. So our input value this time is -1. We're going to come over to -1. We're going to pick up the two output values for the blue function. The output is a 1. And for the red function, the output is a 3. So they're asking us to take 1 times 3, which is going to give me 3. Then finally, f divided by g. Again, the order matters here. F function at 6, so we're going to come back to 6. 6 is an output of 2 for the blue function. And for the red function, which is our g function at 6, the output value is 5. So we're going to end up with 2 bits. So kind of a fun little problem. It was a pain to draw the picture, but the problem itself is pretty straightforward and reinforces the fact that we can combine functions. So literally, you could graph an f plus g function by literally finding the sum of all the y values and graphing it. Same thing with the quotient, the difference, or the product. And finally, in example 6, there are some true-false questions there. I'm not going to write them on the board. We're just going to try and answer them. So on example 6, part 8, it asks, every relation is a function. Well, that is definitely false because we saw some graphs of relations that were not functions. Part B is asking us, a function can have more than one y-intercept. Wait a minute. If we have more than one y-intercept, aren't we crossing the y-axis twice? That's a vertical line. That is also false because that fails the vertical line test and is not a function. Part C is asking, the graph of both function always crosses the y-axis. Does it have to cross the y-axis? So what if we did something like that? Well, that crossed the y-axis. What if we did something like that? Does that cross the y-axis? No, we saw one of those. So that's also false. It does not have to cross the y-axis. It also doesn't have to cross the x-axis. Part D asks, the y-intercept of the graph of the function whose domain is all real numbers is f of 0. So we're always going to have, this is asking us whether or not the y-intercept is always on the origin. Well, no, that is true. The y-intercept of the graph, whose domain is all real numbers, is f of 0. Oh, that is true. I'm sorry, I had to read that correctly. Let's go back to that again. F of 0, this is saying the input value is 0, and that corresponds to the y-intercept. So the y-intercept would be 0, something. So that's true. Sorry, I had to read that one again just to make sure I was doing it right. The last part of that we can't actually do yet, but it's a look ahead. It says, even functions have graphs that are symmetric with respect to the origin. We haven't talked about that yet, but even functions have symmetry to the y-axis, so it's a false statement. We'll come back and take a look at that statement again in a later section. So, and that wraps up section 3.2.